Hello everyone, this is KP the Math G. I have done quite a few of these calculus videos on just AP Calculus alone, the AB section of it. So it's been a while since I've been back online. I've done 146 of these. This is going to make my 147th. But I'm glad to be back. I just well, you know, when you're retired, you got this and certain things going on, and we just, you know, a little traveling to do, and so having said all of that, I am back to give you some more videos. How many more, I'm not sure, but definitely at least 150. And maybe more than that, and I may get off on other topics as well, all math topics, but other things as well. But be that as it may, we got a nice problem here, and I decided to pick part B of this problem, and it says, and you know, having such a small board here, I just kind of abbreviated here and there, but it says a company designs spinning toys using the family of functions y equals cx times the square root of 4 minus x squared, where c is a positive constant. X and y are measured in inches. It says each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. You can kind of get a picture if you were to get the picture of this. This is a top probably of some kind, a spinning toy. I don't know if some of you know what a top is, but when I was little, we had a little string at the top, and you just wrapped it around the spinning around the top, and then you pulled it, and it would spin on the floor or whatever. But we had a good time with that. I do eventually want to do another video on C, and I'm going to leave A, well, for you to try to figure out, but now I will do A if you request it. This is a very good problem. I enjoyed working this. So you have to know something about the nature of a derivative. Now this thing says, in this case, for y is equal to this function, cx times the square root of 4 minus x squared, dy over dx. So they already found for you. It is known that the derivative is c times 4 minus 2x squared divided by the square root of 4 minus x squared. So they have already found dy over dx for us. We do not have to do this. It says the radius of the toy it's a cross section, the highest of, you know, let me see if I can read that part B where they can write it better than I can say it. So it says for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C for this spinning toy? Now, I'm taking it that this is, we're going to guesstimate about where the highest point is, somewhere in there, and this highest point right here is, well, think about this. This function is y, isn't it? All right, so this height is y. This height is y, and y equals 1.2, and that's going to be in inches. We know that for a fact. So what we can do in place of y, then, we know that's actually, which is the same as the radius r, because you know when you spin this around, this is a radius, right? All right, so but this is the highest point. And something else we know, or we should know, or be reminded of from time to time, is that this highest point is going to, we have a horizontal tangent to that line at that point, don't we? Alright, and so we can, at any point really, not every point has a horizontal tangent, but at the highest point we do have a horizontal tangent. And what is the slope of that horizontal tangent? Well, you know that m is equal to 0, which means really that we set this derivative. This derivative is where you remember when you do maxes and mins? Well, this is a maximum height. So when you do maxes, in this particular case, dy over dx is equal to the slope. The slope is 0. The change in y over the change in x is 0. So what we have to do is, we know that this is two problems actually. Alright, so cx, alright, well, y, which is, we can go ahead and do it this way, cx times the square root of 4 minus x squared. We know that that's equal to 1.2. Alright, and so actually we have that going for us there. Alright, and then also the derivative itself, which we'll probably put on the other side, is equal to 0. So we're going to do this part first. Just to understand that you do know this height is y. Well, I know what y is. Y is this. Okay. We're going to set it equal to that height right there. And that's what you have to be able to recognize. Okay. So anyway, be that as it may. Hold on, my phone is ringing. I apologize for that. Alright, I don't think it's alright. Well, nothing important evidently. They quit calling. So they'll leave me a message if they want to talk to me. Alright, and I can call them back later. Alright, anyway, be that as it may. Now, one thing that will help us is that we need to kind of get an idea of, you know, let's see. Now, well, I want to deal with this a little bit later. I'm looking at it backwards is what I'm doing here. We do not, see, we have two unknowns here, so we cannot solve for any one particular variable. So what we want to do is we can solve if we set the derivative equal to 0. We can actually solve for c, and then we can find that value of c that way. Let me think about what I'm trying to do here. Okay, well, we can solve for x and then we can later solve for c. Yeah, that's what we're going to do. Alright, so we're going to use the derivative here. We're going to leave this up here. Alright, let me turn this over where we can have some working room. Let's see. Alright, so, alright, I've got it right here. Alright, so now dy over dx is 0. Alright, and then this is equal to c times 4 minus 2x squared all over the square root of 4 minus x squared. Now we got to assume that since this is in, that graph is in quad 1 and so on, that this denominator is not 0, because if it were, then we would be in trouble. Okay, so we can multiply both sides by the 4 minus x squared. Okay, square root of 4 minus x squared. Alright, so times, let's just do it up here, 4 minus x squared, and we know that this is, we're down now to just 0 is equal to c times 4 minus 2x squared. Now I can distribute the c at this point and then solve for c very easily. So I'm going to do that. So 4c minus 2cx squared. And I am actually wanting to solve for x. Alright, so here's what we're going to do here. We're going to subtract 4c on both sides. Subtract 4c on both sides. And now I've got a negative 4c is equal to, this is 0. Alright, a negative 2cx squared. So now we're down to just dividing by negative 2c on both sides. And boy, it does work out. X squared is equal to positive 2, which means that when we take the square root of both sides, now remember this is plus or minus, but since we're in quad 1, we don't need a negative. So, alright, so length is not negative anyway, so positive the square root of 2. We need that. That's what you use to solve the rest of this. Now recall, let's go back, x is equal to the square root of 2. Recall this now. Now since x is the square root of 2, we can easily solve for c. It's kind of like a system of equations here, and that's what we're really doing. So c times the square root of 2, let's see, 4 minus the square root of 2 squared equals 1.2, like this. A little bit of algebra involved in this, and when you do calculus, you gotta remember how to do your algebra skills. So let's see here. This is just the square root of 2 times c. All right, and then times the square root of 4. The square root of 2 squared is just 2, so 4 minus 2 equals 1.2. And that's going to be 2 right there. So let's see if we can put it over here. Oh, wait a minute. Let me turn it over on the other side. Let's use a different color so we can distinguish the two equations that we got. So square root of 2c times the square root of 2 is equal to 1.2. All right, so here we go. So right here, the square root of 2c. All right, where am I at right here? Yeah, times the square root of 4 minus 2, which is 2, and that is equal to 1.2. All right, I wrote it the other way. Well, the square root of 2 times the square root of 2 is the square root of 4, which is 2. So 2c is equal to 1.2, and now when we divide by 2 here, c is equal to 0.6. And that's your constant there for this. That's what c needs to be to calculate, when you have this height, this highest point right here, c needs to be equal to 0.6. Okay, so that is, it's going to always be positive. So what you had to do was you had to think, once again, that this height is y, which is r, this radius is r, which is this. Alright, so that is equal to 1.2. We already knew that. That's one thing you had to establish. And then the other part is that this derivative here, this slope is equal to 0 here. And then when we solve that over here like we did a while ago, well, we solved this and got down to x. It's nice to get what x is, because if we don't know what x is, we're not going to be able to find c. Alright, so we found x. And so after we got that, we plug it back in right here. Alright, so right here, the square root of 2, the square root of 2 right here, and then of course now finally, and I'm sorry I keep flipping this over, but we finally get down to 2c times the square root of 2. Now remember, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. Alright, so we get down to 2c is equal to 1.2, so now c is equal to 0.6. And that's what you have to find, is that value of c. Recognizing, once again, that your derivative is equal to 0, because that is at that That's your max, okay? Alright, and then you had to realize also that this again is your height here. Your height is equal to 1.2. So you're actually really solving a system of equations. Well, that's all I have. I'm trying to run these videos a little bit shorter and everything, but anyway, I think maybe you can grasp and understand a little better. Anyway, this is KP the Math G about to sign off. Please, if you haven't subscribed to this, please do so. And if you hit that like button, you know, I'm already smiling thinking about that like button and everything. And for those of you who are hearing this again, you probably know me well enough to know that I always end with a signature clap. So that's what I'm about to do now. For those of you who are just now tuning in, whether you be an instructor or whether you be a student, I end with a signature clap. So here we go. This is KP the Math G signing off. Ladies and gentlemen, have a great, great day. That's it. Well, let's do it again. I'm rusty. Let's do it again. Ah, that's so much better.